Thanks. Rick wrote me in, so this could be relatively quick. But I'm just going to talk to you today about some recent work that we did at Mary Kathleen, pretty much the start of a project. So the aims of this project are particularly to develop new and sustainable methods for extraction of rare earths, and Rick's leading the program, and there's multiple parties involved at the University of Queensland. Our section is particularly look at plants and whether there's any application of phytomining, so using plants to extract rare earth elements. And initially this year we're doing survey of soils and plants growing in association with rare earth deposits in Queensland. And last month we actually got to get out and do some field work and collect plant samples together with UAV imagery at Mary Kathleen and the nearby rare earth exploration leases that Hammer Metals has. And in this talk, I'll show you a bit about what we did while we were there, and then just talk a bit about comparing the resolution and spectra of the UAVs that we have, and what other options we might have. So just obviously you've probably all heard the word drone. So just as far as terminology goes, I mean, initially they were known as UAVs, and people still use that. So that just means unmanned aerial vehicle. And drone was, the militarized sense, and therefore drones are evil. Equally now, CASA calls them remotely piloted aircraft systems. So this is the current system that I'm using. We've used a range of different products over the years, and most of our investigations have been around rehabilitation of mine sites rather than exploration. This particular UAV has a multispectral camera, which you can see the bands below, which two of the bands correspond with some of the sentinel bands that Imam was talking about previously. Now, obviously, drones are obviously, they fill a new role. As you all are aware from the previous presentations, I mean, satellites have been around for a while. Manned aircraft have also been around and have been doing surveys. And drones are at this interesting point where the sensors are needing to miniaturize to a point where they're actually useful. And that's progressed quite rapidly over the last 10 years, but there's still some way to go for them to be an effective tool. Now, drones are different from aircraft, or they're similar, but you're generally collecting imagery that is, or data below 120 meters in elevation. So you're quite low to the ground, and a lot of UAVs can be relatively fast through the air, or you can have them stop to take imagery. But on the right-hand side of that image, there's a grid pattern that is flown above a target destination, and it's flown as a grid, and images are taken generally with, if you want a canopy model or a digital surface model, you'll have very high overlap. So we're talking 90% overlap between each individual photo. And that allows you to build quite complex and detailed, 1 to 2 centimeter digital surface models. And that image also is just demonstrating that, depending on what sensor you're flying, you can have multiple and specific wavelengths collected. So the recent work, this is a recent planet image, from August actually, of Mary Kathleen, and you can see around the pit area where the green dots are just where we collected plant and soil samples, and the tailings dam is up on the top of the picture. And then towards the bottom right is the Hammer Metals Kopani rare earth survey area. And so today I'm just going to show you a few images from the pit, the processing and mill area, and also from the exploration area to the south east of the pit. So the Kopani exploration lease, Hammer Metals has done drilling. Well, on the left-hand side, this is they've done a bunch of soil samples, and those pink individual dots are where someone got to walk across the area. And now that they've done those, on the right, I just did a interpolated kriging of what the cerium concentrations were, and you can see in the middle of their exploration lease their values up to 15 parts per million, and so that's where we targeted our assessment of the plants in that area. So if you look at imagery from Planet, and this is somewhere between 3 and 5 megapixel, the pink dots again are the where the soil samples are collected. You can sort of see a brown smear towards the right, and that's a new road that they've just put in to go further with their exploration drilling. And on top of that, so we climbed up some of the ridges, and I'll show you in a second. And each of those points are where we collected imagery above the site and with the drone. And so you can see that, you know, once you stitch that together, you get quite a high detailed map of the most interesting part at this stage for Hammer Metals and the area of the highest cerium concentration. Now, if you zoom in closer, I guess one thing that was noticeable there is that there's also a difference in the vegetation. So on the far left is mainly spinifex related, and in the center you can see that the vegetation is a lot more bare. So in that case, that's copper grass, which is Ariadne. And so you have a different, you can already see in these, at this stage, unexplored areas, there's actually an indicator or a plant indicator that can be used, and copper grass has been used for copper deposits in the past. And so we were looking for other species that might also be an indicator of rare earths potentially. Of course, it's a lot easier to use a drone than it is to climb up some of the hills. And apparently the Kalkatoon people who lived in this area, this wasn't an area that they accessed too often because it is very rough country. So it's very nice that they built a road for us to get there, and we only had to climb up from the bottom of the valley on the right. Now, moving from the exploration lease over to Mary Kathleen, prior to going there, we thought we'd worked out a way we'd used tailings material, and with what some of the signals that we had, that we could use handheld XRF to locate areas of high concentrations of rare earth elements. Now, in the end, that technique didn't work, but we did know that the rare earths were associated with the uranite ore, so we used the Geiger counter as a proxy for what we thought should be high rare earth areas. And you can see here, this is a false color image from the stitched imagery from the drone, and the red highlights the green vegetation, and you can see we sampled on the benches where areas were relatively high in potential concentrations of rare earth. Some of the other things you can get out of imagery is, point cloud. So this is a rendition from the 400 photos that were collected over the top of the pit, and so you can pretty much in virtual space, move around in that area to look at where you might collect and where things might operate. Now, over in the other area, the Mary Kathleen mill and processing area, which was cleaned up, there was still, well, prior to closure, there was still a lot of relatively radioactive material. So those were the areas that we looked and collected plants to look at rare earths. So particularly in the bottom of the picture, there's a creek line, which there was Spania, which was common there, and would be a good candidate species. And we're just at the moment still processing the plant samples with ICP-OES to look at what rare earth concentrations the plants have. And again, a closer look, this is now Spania is not a very good target plant for. So on the left, there's the green dots where we collected it, and you can see its canopy is not really a full canopy, so it's a very sparse canopy, so not a great target for even high resolution drone imagery. And just to give you a bit of context, this is what the area that I just showed, and it was circled in the middle, and that was the processing plant that was there up until the early 1980s. And just to give you another view from what the drone can collect, on the left is another historic picture. On the top right is again the point cloud, which is a true color, image of what's there now, and then look at the remaining infrastructure and the collection area that we collected. And so to finish off for today, we have a lot of further work to do. The imagery Imam will get to process further. Only just process it this week. So we'll look at potentially also borrowing someone else's hyperspectral drone setup. We unfortunately don't have one. We're also in the process of doing the chemical analysis, as I said, of the soils and plant samples. And hopefully we will also go back and access and look at some of the areas of interest in future with a hyperspectral imaging system that we can carry on the ground and look more closely at the plants. So thank you, and I'll hand it back to Rick.